I forget to start recording. Then I I okay. So let's start now. This has the mass m. This has the mass big M. So I hope you still remember the coefficient of friction. So that has a formula that is mu times the normal action. It's a friction. And find the maximum value of h such that the block can remain on the plate. So because when a small m just touch or just lands on the plate, there are friction between the plate and the block. Then the block will slide over the plate, but also because of the friction, the plate will move forward in the same direction as the block. So the block will slide over the plate. So what does mean by remain on the plate? So that means it almost want to fall from the plate. And at that time, so if there's no friction, then it will not slide over the plate. When will they have no friction? Actually, when they have the same velocity, that there will be no friction. So let's say if they have the same velocity, and now let's say the velocity is v, okay, and then the velocity of the block before lands on the plate, then we can make use of the energy to find it. So just the loss in GPE, that is gain in KE. Okay, then you find the U is square root 2GH. Then, okay, when the block lands on the plate, so we consider this as a collision. But there's no friction on the slope and also on the table, on the ground. There's a friction between the block and the plate. But if you consider the system of the block and the plate, there's no horizontal net force acting on it. So that means the momentum is conserved. So you can write down one formula like mu, that is the initial momentum. That will be equal to the final momentum. Okay. So we've got these two equations now. So and also because you also need to consider friction. The most easier way to consider friction is the object's small m will slide along or on the plate, so that means there will be some energy loss against friction. So then you consider initial total energy is half mu squared. Then that will equal to the total final Ke. But the final kinetic energy is more than the initial one because it's lost in energy loss due to friction. Then the friction has a value that is mu small m g. And then this is a friction, the friction. Then how can we find the work done against friction? We multiply by the displacement, that is L. This is the distance of small m slide over on the plate. Then you solve these three equations. Then you can get the maximum value of h. That's it. Simple, is it? Very simple, is it? The u, let's substitute to be square 2gh. Let me do it very fastly, okay? I use some trick to solve it. But you don't know this trick, so we don't really have time to talk about all the tricks. So the answer is A. Okay, you may try to solve it by yourself, but I hope you can understand these three formulas. So one energy, two equation is about the energy, and one equation is about the momentum. Okay, you capture your screen? I captured already. So then let's go to another one. Okay. A main question is quite similar to this one. So let's go to one very similar one. Let's say this one. So also an object, okay, and also an object in moves along the plate, and then there's a coefficient of friction. There's friction. So let's have a look at the case one, case A. The masses, they're all small m, okay? We simplify the case a lot. So find the minimum U that the A can stays on C. So that means a object this mass has slide over the plate B already, and almost is at the is on the plate C. So what does it mean by minimum? And the next one is about the maximum. So for minimum U, that means it can just barely land at the left right side of C. For maximum, and then it can go to the right hand side. So and it can just land on the left hand side of C. So that means at that time, these three objects all will have the same speed, all will have the same velocity. So then you can write it like the initial momentum is mu. Then the final momentum will be VMV. Okay. So one formula. Another one, you need to use the energy. The initial KE equal to final KE, but there is a energy loss due to friction. So you need to add that part. So that is mu mg times L. Then you solve these two equations. Then you finish the part A. Okay. And then for part A is simple. Part A is simple. It's a very standard question. But for part B and C, you can do it together. If you can see the question, okay? You need to find the final velocities of A, B, and C. So first of all, if it can land at the right hand side of C, so let me draw the velocity of the object A when it lands on the object C. Let's say these two at the velocity v1, and then each must have a velocity that is larger than v1, such that it can still slide over the object C. If the v2 is v1, there's no tendency of the motion between these two objects. There's no friction. Then the object can then there's no friction. That means they will, and if they have the same velocity, of course, there's no relative motion. Or you can say the object A will not slide over the object C. Then okay, at this part, okay, you need to let the v2, v1, because you need to solve the v1. And now, do you know there's a friction between this object A and object C? The friction has a direction like this. On the object A is backwards, on the object C is forwards. So you know object C will accelerate, such that B and C are no longer touching each other. So that means when A lies on C, then the velocity of C will be larger than that of B. And actually, it means that the final velocity of B is also v1. So that's why I need to let v1, v2. So finally, and then the velocity will be like v1, and then these two have the velocity, the same velocity v3. Okay. So that means I need to solve the v1 and v2 first. So first of all, we need to use momentum, of course. So mu is a initial total momentum. Then total final momentum will be mv2 plus mv1 plus mv1. And then also you can make use of the energy. Don't forget there's energy loss due to friction. You need to count how many unknowns you have in the equation to see if you are able to solve it or not. So here you have left two unknown, v1 and v2. So we have two equations. Then that's enough. Two equation, any equation can solve maximum n unknowns. Then you can solve it. Okay, you can solve v1 and v2 from these two equations. But that's not the end. We also want to solve the v3. Then actually, object B is no longer touching A and C when A lies on C. So you just can consider the system of B and C, A and C only. So the initial momentum will be mv2, and that equal to plus mv1, that will equal to 2mv3. And also make use of the equation of energy to do it once again. Yeah, this question will be difficult to solve it. But it counts for 15 marks. So do you know, you just need to solve 4 equations. Also for the part A, okay? Part A just 2 equations. So that means in total there are 6 equations. Then you can get 15 marks. That's really a lot. Two mv3 squared plus mu mgl. That's it for this one. Okay. Even though if you can't solve it, okay, if you write down the equation, I think at least you may get 8 marks, 9 marks, or 10, or even 10 marks. The equation is more important than how you solve it. Okay. If you don't really have time, I don't think so. So you write down the formula first. Okay. Then let's move on. So this one, question 7. A wedge of mass big M and H. Okay, and you have a look. Find the minimum value of U such that it can pass over the upper end of the inclined plane. Now when the small n can pass over the upper end, so that means when the small m moves relative to the big M. So when the small n can just pass over the upper end, that means it has a relative to the big M, it must have a velocity that is larger than 0, the relative velocity that is larger than 0. But of course, at that time, the velocity, the object M is moving forward to the left, and larger than 0. So that means if you want to find the mean value, just consider it to be 0. So that means you just consider the object from here to the case when these two objects have the same velocity to the left. Then you can apply the conservation of momentum and also the conservation of energy. So for conservation of momentum, you need to consider horizontal momentum conserved. The vertical momentum is not conserved in this case, but it's difficult to determine actually. What I would say is in most of the case, the vertical momentum is not conserved. Then I can write down the horizontal momentum conserved like this. The next equation is a conservation of energy. That's it. That's it for you to solve the question 7. Any question? I hope it will be simple enough, at least for this question. Let's move on. Let's have a look at question 24. This is also a one common type question. We take a look first. Okay. Now this is about conservation of energy. So in this case, initially this is at rest, and when it's in this shape, L shape, it's also at rest. So we just consider the conservation of energy. Now, first of all, we need to Now what we can do is now this object will change the shape. So you may consider this as two parts of the object. And what you need to do is to find the center of mass, the position of the center of mass from the point P. So let it to be M, this to be M. The center of this object is here, the center of this object here. Then if you want to find the center of mass from the point P, so this has a length L/4, is it? Here. And this has a distance L/2. So M times L/4 plus M times L/2 divided by 2M. Then what you get, it will be 3L/8. Is it? Yeah, it is. I think so. Yeah, it's 3L/8. Actually, if you don't do it like this, you can still get the answer. It's just the middle point of these two centers. So this is how you find the center of mass. Now, because in this case there's no change in kinetic energy, so that means there's also no change in potential energy. The center of mass of the object should not be changed. So initially the center of mass of the object should be L over 2 cosine theta, is it? This is has a length L over 2, and then L over 2 cosine theta. H equal to 3 L over 8. Then, okay, very simple. Then you can get answer A. Okay, just give you a few seconds. Done? Okay, then let's move on. We've talked about this. We also have talked about this. Ah, this one is difficult. Question 3. Difficult to maybe difficult to understand the question. What do you mean by total mass? It varies over year, so it doesn't really matter. So let's have a look at this one. Okay, this one should not be really difficult. You have a look at it. So these two masses are not the same, and then they stick together after collision and move to the right. So first of all, you need to think about which one has a larger mass. If you know about it, and then you can sort out two choices. I think it's very obviously, okay, very obvious. They stick together and move to the right. So I think it's very obviously the mass of A is larger than the mass of B. So of course D and B are not the answer. Okay, very obviously. Wow. So first of all, let's find the speed when they collide. So you just make use of conservation of energy. So the loss in GP mgr, that is half mu squared. Then the u is square root 2gr. So let them then we find the masses. Sorry, we make use of constant of momentum to find the velocity after they collide. Now we know that this one has a larger mass. So ma, let the direction to the right be positive, plus mb negative u. That should equal to 2mv. Sorry, not 2mv. ma plus mb times v. Okay, so this is a formula for constant of momentum. Then how can you relate the R over 4? So they stick together. You can just consider as a whole object with the mass big M, maybe. So just half big M B squared equal to mg R over 4. Okay, then that's it. I forget the answer. I think it's the answer C. Okay. Any question? No? Then let's have a look at question 8. Incline at 30 degrees. And then the coefficient of friction, the mu, is 1 over square root 3. The work done against friction before the particle comes to rest is blah blah blah. Okay. Now, the fraction we have the formula that's mu times n. Now remember, in this case, the normal motion is not mg because the normal motion is not vertical. Here's a value that's mg cosine 30 degree. So let's calculate the value of friction. The mu is 1 over square 3. Mg cosine 30 degree is root 2. So the friction has the magnitude of half of the weight. Okay. So why you need to find the work done against friction? How can we? Why is not equal to E? Because when it moves upwards, there is also gain in potential energy. So let this distance to be S. Okay. Then your kinetic energy will lose and totally, and one part will be gain in GPE. So that is mg s times sine 30 degree. Sine 30 degree is one half. The height is mgh, the h is s sine 30 degree. So that is mgs 102. And then the work done against friction will be the value magnitude of friction, mg2 times the distance travel of this displacement. So actually, what you can see is the gain in GP is same as the work done against friction. So that means half of kg is lost as work done against friction. So therefore, the answer is D for dot. Okay, very simple. Yeah, is it done? Now, at least you can do the part A. So initially, the objects are at rest, and then they are separate into two parts after explosion. The explosion is just a opposite as the opposite to the collision. You can still apply the concept of momentum in this case. So that means the initial total momentum will be 0. Okay. Then let the velocity on the right hand side to be positive. So the mass of B times its velocity, that is TV, and then plus the mass of A times the velocity of A. I think you can really very simple. Simply you can solve the T, then you can get 2 marks. Easy, yeah, very easy. Olympic question is always easy. Why is 26.2 here? Who write this one? I don't know. I don't know who write this one. I'll just leave it. Okay. I can't delete it. What I can say is just you have a look at my textbook first. Okay. First of all, we are not aiming at any price in this commission. We just have a trial in this commission. Yeah. I'm not expecting you to get a prize in this commission. Because only 10, around 10 students can get the commission. Yeah. maybe we stop here today, and tomorrow let's go for one of the most simple topic is about the gravitation. Like it's really simple. So after we have talked about that, we can really finish these kind of questions easily. Okay? Easy, really easy. So then let's meet you tomorrow. What time? What time you like?